Hey, Saxon Course 2, Lesson 56 is on plotting functions. So here, Jamal is ordering chairs for the furniture store. The function table shows the number of chairs he orders for each table. Okay, so write a rule in words that shows the number of chairs Jamal orders for each table, and then it wants me to complete the function table to find out how many chairs he ordered if he has 5 tables. And then C, write the rule for the function table as an equation. Use the letter Y to represent the number of chairs and X to represent the number of tables. So if we look, we have on table 1, there's 4 chairs. With table 2, he has to buy 8 chairs. On table 3, if he has 3 tables, he has to order 12 chairs. So my rule is that to find the number of chairs, I'm going to multiply the number of tables by 4. So you're going to multiply the number of tables by 4. That's my rule. Multiply by 4. Okay. For B, I'm going to complete the function table, so I'm going to multiply 5 times 4, which is equal to 20. So he'll order a total of 20 chairs for 5 tables. Often the rule of a function is expressed by an equation with x for the input and y for the output. So to write this as an equation, I'm going to put y equals 4 times x. And x is my tables, because I multiply the number of tables by 4. So y is my chairs, and x is my tables. So y equals 4 times x. Now, in the function, y equals 2x doubles every number that is put into it. If we input a 5, the output is 10. If we input a 10, the output is 20. Below is a function table that shows some input-output pairs. Graph all pairs of numbers on this function. So you begin by graphing the input-output pairs on the function table. So if you put in, if your x equals 1, then your y equals 2. If your x equals 2, your y equals 4. Okay, so you'd put all those dots in. So you 0, 0, 0, 0, 1, 2, over 1 up 2, 2, 4, over 2 up 4, 3, 6, over 3 up 6, whoops, missed, 3 up 6, 4, 8, over 4 up 8. Okay. So that's how you would graph that function upwards. Now you can also apply this to negative numbers. So you could extend this graph down and to the left, and you would take these dots and form a line, which hopefully goes through all of the dots, which is hard on this. So that line's going to continue below in the negatives as well, because if you put in -1, you would get y would equal -2. Okay, and it would continue along this line. Okay, on this one, this illustration shows the graph of a function. Refer to the graph for A and B. Write the coordinates of the 3 points on the line that represents the function. So I'm going to just pick 3 points. So 0, 0 is one of those points. So I have 0, 0. Okay. Another point I have, the next one on there is over 2 up 1. So the next one is 2, 1. 2 on the x, 1 on the y. And the last one is over 4, another one is over 4 up 2, because it goes over 4 on the x and then up 2 on the y. So those are just 3 points that I chose. I could have chosen points in the negative, okay, and there are lots of other points I could have chosen. But it's easier to use whole number pairs. Okay. This one was 4, 2. For B, using x and y, write the rule of the function as an equation. Do all xy pairs from part A to satisfy the equation. So I chose these 3. So I'm going to figure out I need to do a y equals something. So if you look, y is going to be half of x. 2 divided by 2 equals 1. 4 divided by 2 equals 2. Okay? So y equals 1/2 of x for each part on the line. Okay? And so you could even put in these numbers. So put in x equals 0, what does y equal? Well, 1/2. So if y equals 1/2 times 0, y equals 0. So that's correct for this one. Okay, on the next one, we have y equals 1/2 times 2, because this is x, and y. 1/2 times 2 is equal to 1, which is what I got. Okay, so this equation works for this function. Okay, that's it for this lesson.